And I'm going to be going over 9.1 today, and then questions, homework questions. But first, let's visit 1 week of class left. Let's visit that again. Can anybody tell me why I go over this 3 or 4 days in a row?
Because somebody will ask.
Because somebody's going to ask. So I'll go ahead and I'll cover it again. All right. The last day of class is Wednesday, July 22nd.
Yes.
Therefore, the last day of class for Math 120-12 is Tuesday, 7/21. Okay. So for my online class, I got 2 online classes, and I've got Math 140. The 2 online classes and Math 140, their last day of class is 7/22. Okay. For this class, Math 120-12. For Math 120-12. Right now, you are responsible for 8.1, 8.2, and today, 9.1. So those are, right now, you're responsible. After today, you're going to be responsible for that homework. So that means if you've done the homework, you are responsible for it on test number 4, which is your last test. Last test and final exam will start on the 22nd or 23rd, 7/22. And will last, somebody look up the final exam date. When is the last day of final exams?
The 27th.
The 27th.
7/27. Now, this is not all that you are responsible for. If I get the Tuesday is your last day, if I get into chapter 10, then your test will have chapter 10 on it. So this area right here will depend on Tuesday. More than likely, I'll probably be going over more questions Tuesday, and I'll go over 9.2 if I even make that. I don't think I'm going to make it to 10. Okay, so probably talking about 9.2 right here. Do we go over 9.2 in the outline? Somebody look in your outline. I think we do.
Yes.
Okay. I doubt very seriously we'll make it to 10. Now, the online class is responsible for 10, so they have to teach yourself, and they can use the videos from last semester, but we're only going to get to 9.2. All right, so the final exam is cumulative. So if you want to review, go to your grade book and review your old test. You can also review homework in your grade book. That's what grade book is for. The final exam will be 2 hours. Usually 33 questions, something like that. And of course, you have 5 days to do it. The last test will be like your normal test. It'll cover whatever we cover up until the last day. And it'll be 90 minutes. And it will cover whatever we cover. And you'll have 3 attempts. Takes a higher of the 3. Here, the exam, you have 2 attempts. Takes a higher of the 2. Now, if there's any homework that I haven't assigned, I will take it out. The only thing, homework, the only thing that you'll be graded on is what I have what?
Already gone over.
What I have covered, exactly. So I don't need any emails from the 12012 class. I don't need any emails talking about, well, what if we didn't do this or what if we didn't do this? Okay. Now the 120 online class, they've got to cover all the way through 10 because that's the benefits of being on an online class. You got some benefits and some not. I might adjust their test, but there's so many that are ahead, I doubt I'll be able to adjust it. Okay, any questions about the last week of class? That is the second time. Go ahead, what?
So will the homework be due when the test is due? Or
last day of class. Homework is due midnight on the 22nd.
Okay, thank you.
Homework is due midnight on the 22nd. Okay, so that's the second time I've covered that. All right, let's look at 9.1. Now, I do realize some of y'all sent some questions. I saw the questions. I think I've done about 5 or 6. I didn't do all of them because 1, I've already covered some of them, and 2, they're the same questions. So I just kind of went through the first 10 and picked out problems that are similar, and I did those. So I've got about 4 or 5 to go over from chapter 8, but I got to get 9.1 under our belt. Now, what are we doing in 9.1? Well, 9.1, you're going to be talking about confidence level, confidence interval, margin of error, and N. Okay, so confidence level, confidence interval, margin of error, and put a note that sometimes you'll see that called Big E. I call it Mo. And N is the number of people or number survey. So in other words, to have a 95% confidence level, what size group should you survey? And this is what we're going to be doing in chapter 9. Now I'm going to highlight the confidence level because most of the time the confidence level is going to be given. The confidence level is going to be given, and it's the dictator. It's usually going to be given, and it usually dictates everything in the question. The other 3 are the things you're going to be given. Now, before we get started, we're going to make an index card. And this index card is going to be helpful for you if you ever take another test in statistics or probability, whether it's in a classroom or not. I tell students to put this on an index card. Of course, out of 30 students, Miss Billy and Miss Woodward will probably do it, and Mr. Yates maybe, but he's a guy, and guys are usually, they already know everything, so, you know, it's hard to get guys to do anything. Right, Mr. Yates? Is he here today? I don't think he's here. I ain't heard him. All right, so I'm going to pull out the Excel spreadsheet. I'm just going to do it on the Excel spreadsheet because I can get it all on one.
Would this be on the GRE?
And it's not very big. It's just, I'm sorry. What?
I said, would this be
Yeah.
on like a GRE?
Yeah. That's a GRE is a standardized test. When you hear me talk about standardized test, I'm talking about practicum test. I'm talking about placement test, SAT, ACT, GRE, what's it called? The TEAS test in health, all of those. There we go. And I'm just going to, and this will be called confidence levels. So if you want to put a title on the very top, then go ahead. Okay, and this is going to be the first column we're going to call CL. And that's going to drive me bananas. Bold, underline, center. There we go. And we need to make these bigger. Let's make it 14. Yeah. Okay. And 0.99, 0.98, 0.97, 0.96, 0.95, 0.94, 0.93, 0.91 or 2, 0.91, and 0.9. Now, why am I not going down below? Why don't I have 100, and why am I stopping at 0.9? Can anybody tell me that? And you can put these as percentages if you want to. Where's my percent button? There it is. There we go. So can anybody tell me why I didn't put 100? Come on now, I've been saying this all through this class. What do you stay away from in probability and statistics? You stay away from concrete values. What's wrong with 100%? What concrete word goes with 100%? Starts with a P.
Perfect.
Perfect. And why? What's wrong with the word perfect?
Nothing's perfect.
Exactly. Although you will meet some people in your lifetime that think they are perfect. Okay, so I didn't use 100 because it's perfect. Why didn't I go down to 75%? Why did I stop at 90? Miss Billy, they're taking off one of the Golden Girls episodes. Have you heard about that?
Why?
Because they go to the spa and they get mud on their face, so they're taking that episode
Yeah,
off.
I know that episode.
My daughter, I ain't gonna say what she said. She said that was stupid, but anyway.
I love the Golden Girls.
She does too. She loves the Golden Girls. Why didn't I go to 79, 89%? Well, let's say that you're in a job interview. What do you want to put forward? If you're in a job interview, what do you want to do? You want to look your best effort, right? Is 89% your best effort?
No.
No.
Is 72% your best effort?
No.
So when you're talking about in the future, whether it be in a job or whether it be doing your research for your master's, you don't want an 89% confidence level. Most of the time, the book will ask for a 99%, a 95%, or a 90%, most of the time. Now, the computer regenerates the homework and the test questions, right? So what does regenerate mean? That means that they might regenerate the percentage. And sometimes on a homework question or a test question, you might get an 89% or you might get a 72%. The reason you don't worry about that is because that's a homework question or a test question. But in real life, you want to stay above what? 90%. Okay? Now, that means alpha is right here. Let's see if we can find alpha. Dang old inverts. Dang old, where's my shapes? Symbols. Where's symbols? Symbol. I'm trying to impress y'all with my ways. Let's see. Math. Okay, we don't have math. Okay, we don't have math. There's no math. Okay, that's good. Greek. Well, that's Greek. Where is just regular Greek? Greek and Coptic. I don't forget what I was looking for. Alpha. There's alpha. Hey, coming. Okay, there's alpha. What is alpha? Alpha is the complement of the confidence level. So somebody tell me, well, we better do this. Let's do this in we're gonna take this off. We don't need to do percentages. Well, okay, we're gonna do percentages for alpha. So that's going to be 0.01. That's going to be 0.02. That's going to be 0.03. That's going to be 0.04, 0.05, 0.06, 0.07, 0.08, 0.09, and 0.10. Everybody with me? Okay. Now you're going to need alpha over 2. So Control C, Control V, divided by 2. So half of a penny is 0.005. Half of 2 pennies is 1 penny. Half of 3 pennies is 0.015. Half of 4 pennies is 2 pennies. Half of 5 pennies is 0.025, 0.03. Hopefully you see the pattern. Half of a dime is a nickel. Now I need you to pull out your handy dandy calculator because I don't want to do it. And I need you to find, let's see if I can do this. I don't know if I can or not. Z subscript. Oh my gosh, look at there. Z, Control C. Well, it's not going to do it. Let me see if I can insert. I should be able to do it. Insert, well, format, subscript, insert. Well, let me insert. I know what I can do. I'll just put in. Why won't it let me insert? Give me a second. I'm playing. Alpha over 2, and that's not what I wanted. Oh, shut up. Alpha over 2. And I want that to be a sub I'm amazing. I'm just amazing. Z sub alpha over 2. So I need you, and I'm going to change all these to 4 digits because that's the area. So I'm going to change that to 4 digits. 4 decimal places. All right, I want each one of you. Now try to pick out, Miss Billy, you do the first couple, and I need somebody to do the next couple. Miss Woodward, if you would do the next couple. Go to inverse norm, and type in 0.0050 and give me that z-score. Positive, this is the absolute value. So what's the first one? 0.0050. What do you get?
I got, oh wait, it's not positive.
Yeah,
think I
go
have to
ahead.
put
Just
it
give
in
it
the
to me.
right-
Just give it to me. The
okay.
absolute value. What is it? 3 digits.
2.576.
Okay, make sure everybody gets that. All right, do the next one. 0.0100.
2.326.
All right, now I want everybody to take a minute and fill that out. And I'm going to ask y'all for the answers here in just a second. All the way down to 0.0500. Just take the absolute value. I don't want any positive or negative. I just want a z-score. So go ahead and be doing that.
New Facebook comment.
Okay, can some of y'all give me 0.0150?
I got 2.170.
Okay. Y'all verify these. Give me 0.0200.
2.054.
And the next one.
1.960.
And the next one.
1.881.
And the next one.
1.812.
And the next one.
1.751.
Next one.
1.695.
And the last one.
1.645.
And that column right there is the column that you need for these questions. I'm going to highlight that in a pink color because that's very important. Now remember what I told you. I told you that the confidence level dictates the question. Okay, the confidence level dictates the question. And why am I highlighting? I don't have a fluorescent. I was hoping they had a fluorescent pink. Why am I highlighting that? Because the confidence level gives you what you need, and what you need is those numbers right there. So if you're taking a placement test at BFE University and they say, give me a 99% confidence level, you're going to do this right here, and you're going to get that, and you're going to look up on your calculator or your table, you're going to look up 0.01 or 0.0050. You're going to look for that 2.576 because this is your areas. I'm going to put right up under here, I'm going to put area. I wonder if I could do this. Shift. I was hoping it. Oh well. Let's see if I could do format. General text. I was hoping. Oh well, forget it. Okay, so if you're given the area, you're going to find the what? The z-score. So you type in inverse norm, and you type, if you don't have a calculator, then you would go to the, and I'm going to show you this for your own information. If you don't have a calculator, you go to the table, and they would supply you with a table if they didn't let you use a calculator. And all you have to look up is Sullivan, since this book is Sullivan z-score table, and then PDF. And then, well, that's working. I don't know why it's, there we go. Hit images. And here it is. And you go into the area, and I'm not going to be able to pull it up. You go into the area, and the area is the body of the table, and you look up 0.0500. I hope it pulls it up where I can see it. Yeah, this is what's in your book anyway. And you go to the Z table, and it'll say Z table if I ever get there. I think I've already skipped it. I suck. I guess that's it. Yeah. And I look up 0.005, and I don't see it on this one. They don't have the negatives. Where's the negatives? Oh, Lord, help me. Y'all not see, that says all positives. Well, I'll look up 0.95. Let's see, what were we doing? Excel. Okay, that'd be 0.9. What would that be? 0.9950. So you go to your table and find 0.9950. I'm trying to find my 0.9950, be down in here. 0.9950 is right between these two. So that's going to be a negative 2.575. So let's see what we got on our handy dandy 2.576. And the calculator is going to be more detailed. But that's how you use the table. Okay? Remember, and write this down in your notes. If you have to use a table, see this area right in here? Well, let's see if I can use let me use my whiteboard here. let me use, hold on. This might help you later on. Translucent. And I'm going to use a line. That's supposed to be bigger than that. Oh, me, oh my. I'm about ready to quit, y'all. There. You see the area that I'm highlighting? That part right there is the body. And what do you notice about all those numbers?
They're all decimals.
So how many places?
Hubert, I'm blind. It looks like 4.
Yes. And remember what I told you at the beginning of chapter 7. All areas are written in 4 what? 4 decimal points. Okay? So the area is in the body. So that means that the z-scores are where?
On the outside.
Exactly. So you need to write that down in your notes. And if you have one of these tables in your book, you need to pull it out and look at it. Not that you need it for my test, but you might need it for, you know, a placement test. Here is the z-scores. So how did I read that a while ago? Let me take my handy dandy turquoise. And I said that the complement of 0.0050 is what? 0.9950. So I got to find 0.9950. 0.9950. 0.9950 is right here. Everybody see that? So I go over here. Well, let me. Why is my boss calling me when I have class? 2.5. I'm about ready to quit. 2.5, and what's between 7 cent and 8 cent? 2.075. So 2.575. And that's how I got the answer. Now, if I looked, if they give me a z-score of 0.42, then I go here and I go 0.4 and 2, and that area is 0.6 whatever. Okay? So if they give you the z-score, you can use this table or use normal CDF, or if they give you the area, you can go back and put in the z-score or use inverse norm. All right. I usually cover that in a classroom setting, but with this, I didn't cover it because with this, it's kind of hard to cover it. So I kind of skipped. I usually do one problem with the table, but I didn't do that in this class, and I think y'all understand why. And plus, some of y'all hug those calculators so much that, it doesn't matter what I show you, you're not going to use the table anyway. So I just didn't show it. Okay, so if you look in your notes, I mean in your book, you'll see that. Okay, so back to the, and some of y'all that hadn't finished it, go ahead. I'm gonna text her right quick and say I'm in class. I don't know why. And I'm going to say, what's up? And she's going to say, just call me. I hate when she does that. Okay. Now, if you have if you have an index card, you need to put this on your index card. Okay, because, and like I say, most of the time you're going to be using that 2.576, you're going to be using that 1.96, or you're going to be using that 1.645. Okay? So what does that cover that we just talked about? Well, that covers this right here. Okay. So what else do we need to know? Well, don't forget p hat. P hat's in there too. We got p hat in here. That's equal to x over n. And q hat is the complement of p hat. So don't forget that. I might as well go ahead and give you I'm gonna go ahead and give you the formulas now. I think we touched on this the other day. Okay, the MOE, MOE is equal to your Z sub alpha over 2, which comes from your card. I'm going to highlight that in pink because that comes from your card. So that's the Z-score right there that comes from your card. Times P hat square root of P hat times Q hat over N. That's how you find the margin of error. The margin of error gives you the confidence interval. Okay? And the only other formula you need is N, because they may ask you to find N. And that's PQ Z over E. N is equal to PQ Z over E, which is the margin of error. Now, we got to find the N to plug into this? No. Usually the N formula is used when it's a different type question. Okay? The question will read, how many people do we need to survey to have a 95% confidence level with 3% margin of error and P is equal to 0.25? How many people? That's what that's for. Okay? If they ask for the margin of error, they're going to give you N. Okay, they're going to give you that. All right, so this page right here, along with the index card, is all you need for 9.1 and a little bit of 9.2. So let's go ahead and look at a couple of examples. And they're on your sheet that I gave you. So let me see if I can pull that sheet up right quick. I hope I didn't delete it. Word. There it is. I don't believe it. All right, write this example down. If you haven't got it, which everybody should have it, write that example down. So this one says, in the parenting cell phone survey conducted by Princeton Survey Research Associates, 800 randomly sampled teenagers in the United States were asked whether they have over ever use their cell phones while driving. Of the 800 teenagers surveyed, 272 indicated that they text while driving. Well, the first thing you already know you've got P hat. Somebody tell me what P hat is equal to. Formula.
X over N.
Okay, somebody tell me what you know about N from the first week of class that I told you.
Is the
Biggest number.
total.
It's always the biggest number. So somebody tell me what the biggest number is.
800.
I'm impressed. So that's going to be X over N, which is equal to 272 over 800. Now, I'm not making fun of anybody here, but there's some things that I shouldn't have to tell you, okay? I shouldn't have to tell you which number is in this problem, okay? And I think that comes from a lot of regurgitation in K through 12. And a lot of K through 12, y'all do a lot of regurgitation and you don't learn things. And that's why I go over something 2 or 3 weeks ago and I asked the same question 2 or 3 weeks later and y'all have purged that information. And I'm like, you can't do that. But anyway, I'm just talking, not saying anybody in particular. You got to quit that regurgitation studying. All right. So I can change that into a decimal. So somebody give me 3 decimal places, because P, I don't mind going 3 decimal places.
0.34.
34 what?
There wasn't anything after. You
So
could just put
0,
0.
3.340. Okay,
Yeah.
so once you got P hat, you have what? Q hat. And Q hat is the complement of P hat, which means Q hat is equal to 0.66, no, 0.6, yeah, 0.66. Y'all check with
Yes.
me.
Yes.
Okay, so that's what you know right there. Now, they don't give us anything, but you be able to find P hat. That's all that question's asking. They're going to ask the next part, I think, in this next part. Let me see. There we go. Okay, so 800 randomly sampled students, blah, 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 blah. 272 out of 800 said that they text while driving. For the problem estimating the proportion of 16 to 17, blah, 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 determine the effect on the margin of error by increasing the level of confidence. Oop, there's our dictator, 95%. So we're going to do 2 margin of errors. One at 95%. And one at 98%. Now, since you've got your handy dandy credit card, your handy dandy index card, somebody tell me what the z-score is for 95%.
1.96.
And somebody give me the z-score for 98%.
2.326.
2.326. And that's exactly what you would write down while you're doing this problem. You look over, because the confidence level dictates everything in chapter 9. Confidence level tells you what to do. So now, let's look at, I'm going to make this big now. So now, I'm not worried about, because they're looking for a confidence interval, because the confidence interval comes after you're given the confidence level. So I'm going to plug into my margin of error. So I'm going to pull up the margin of error formula. Margin of error is equal to z times the square root of p hat q hat over n. Well, I think we've got everything we need. Over here, margin of error equals z square root of p hat q hat over n. All right, I'm going to give y'all 1 minute to do both of those. Y'all get mad at your teacher. I'm texting my boss in the middle of class. Isn't it nice how you have double standards? Now, if I go to a meeting with my boss and I'm doing something on my phone, she'll say, but it's okay for her to call me when I'm in my class. Just like a woman. Oh, I'm sorry. I should have said that. It's one of the reasons I'm single or divorced, because I don't like double standards. Put your boots up. Your boots shouldn't be under the coffee table. And then you go into the bathroom, and the bathroom is like a tornado has hit it. Makeup over here, all this stuff over here, stuff hanging all over the place. Now, what's the difference? Somebody tell me the difference between a pair of boots under the coffee table and a bathroom that looks like a tornado hit it.
When is
The
your
boots
mess
aren't
and when
hers.
is
What?
I said the
when
boots
was your
aren't hers.
mess and when was not?
Okay. First of all, let's Miss Woodward. Let's hear your explanation first. What?
The boots aren't hers, so it's not a mess. That's the mess.
Oh,
Her
okay.
mess isn't a mess. It's her stuff.
It's your stuff that drives her crazy.
Amen.
That's why I'm not married anymore. One of the reasons. The whole point is both of them take away from the room, right?
Yeah.
But one's okay and one's not. I was always told that nobody can see the bathroom.
Yeah. I mean, nobody goes in there really when you have company over.
Yeah, but how many people come over during the week? I mean,
And you can trip over boots.
not under the coffee table unless you're drunk.
I mean,
Now, what did you say, Mr. Yates?
Pretty much what Woodward said.
You've already been trained. Have you been trained, Mr. Yates?
Yeah, I've had the same girlfriend since 10th
Yeah.
grade.
You've been trained. Yeah. Okay. So here we go. I'm going to plug and chug, but I'm going to ask y'all to give me the answer. So equals, and I'm going to put 1.96 in right there. Parentheses, square root of 0.34 times 0.66 over, what was it, 800?
yeah.
Yes.
And somebody give me that margin of error.
I got 0.0328.
0.0328. And margin of error is either going to be a decimal, or they may ask you to put it in a percentage because 3 percentage points. Okay, so in this case, 0.03 or 3 percentage points. So that means, now watch what I do here, because you remember how you did standard deviation? What did you do on the right-hand side of standard deviation to the mean? What did you do to the standard deviation to 1, 2, 3? What did you do? Did you add or subtract? Standard
subtracted,
deviation
right?
to the mean. When you drew a bell curve, what do? Okay, people. You're given a mean and a standard deviation. Mean is 100. What do you do on the right-hand side?
You add.
You add. What do you do on the left-hand side?
Subtract.
Subtract.
Okay, so with the margin of error, P is in the middle, 0.34. What are you going to do on the right-hand side? I'm going to add 3 cents. So what do you get when you add 3 cents to 34 cents? You get 37 cents, Hubert. That's right, class. And when you subtract 3 cents from 34 cents, you get what?
31.
So the p-value is between, let's see, 0.31 and 0.37. That is your confidence interval. Confidence interval is between 0.31 and 0.37, based on a 95% confidence level. And I'll write that again here in just a second so you can see it. Let me go down right here. So if you were writing it in the answer block, it would look like that. Now there are some answers or tests or homework or teachers that want it in interval notation. 0.31 to 0.37. That's interval notation. Both of these are confidence intervals based on a 95% confidence what?
Level.
Level. Now I want you to do the right side, and I want you to do what I did right here with 0.34, because that's p hat, and do the same thing down here. And then of course you're going to tell me what the difference is. It's kind of like standard deviation. It's about the same thing, only you don't go out 3 places, you just go 1 place. Like the first standard deviation on the right, the first standard deviation on the left. Okay, so go ahead and do the second part. Do this side. These people that don't want to stand for the anthem, don't want the anthem, take your ass out the country. I'm sorry, I shouldn't have said that. I'm pissed off.
They canceled the Rose Parade.
I think we should just start canceling out each other. We should just start shooting each other. Just start, just find out something you don't like about somebody and just shoot them. I think people lost their damn mind. Greatest country in the world, and I've lived in several countries. By far, this is the greatest country in the world, and people are acting like, all because they don't like somebody. All this going on because they don't like somebody. All right, you ready? So, margin of error is equal to 2.326 parentheses square root of 0.34 times 0.66 over 800. And somebody give me that 4 digits, please.
0.0389.
0389. Did everybody get that?
I got 0.0390, but it's
Oh, yeah,
all
it rounds up.
Which is still 0.0 what? 4, which is 4%. So 0.9 or let's see, what was it? 0.3. I'm just going to put a p hat right there. I'm just going to do it in my head. What is 34 cent plus 4 cent?
That is 38
38 cent. What's 34 cent minus 4 cent?
That's 30 cents.
30.
So what happens to the confidence interval as the confidence level increases? Look
It
at these
increases,
two
right?
and tell me what happens. Does it get larger or does it get confidence interval? That's a gap. Okay, it's a spread. What does the spread do as the confidence level increases?
It gets larger.
Good job. So as the confidence level increases, so does the what?
The spread.
The confidence interval, which is the spread. Now, next time you look at a poll on the news or in the newspaper or magazine, look down at the bottom at the fine print. And what will they always put at the bottom? The margin of what?
Error.
Margin of error. Anything above 3 is trash. Now, why do you need to know that?
Dude, not listen to fake news.
You're right, exactly. I don't care if you're looking in a magazine, if you're looking in a newspaper, or if you're looking in a whatever, a book. If you see a margin of error of 7%, you can take that page and put it in the bottom of the bird cage. Because why? It's not worth anything. Question, gripe, complaint. Now, that's one type question you're going to get on my test right there. Right there. So write that down as one question. Okay? They give you p hat, and then they give you a confidence interval. Now, I'm not going to ask you to compare. That's two test questions. This right here is 2 test questions. That right there is 2 test questions. 95% and 98% is just tied to the same p hat. Okay. So here's your second test question that you might see on a test. And this is where you got to find n. I feel like I've already done these problems, but I maybe haven't. I don't know if I have or not. All right, go ahead and write that down. Economist wants to know if the proportion of the U.S. population who commutes to work via carpooling is on the rise. What size sample? So you need to highlight that. What size sample? That means find n. So what size sample? I'm going to highlight that, and I'll show you this whenever y'all finish writing. I'm going to write everything down also. What size sample means find n? All right, so what size sample would be obtained? Within 2 what? 2 percentage points. 2 percentage points is equal to mode, which is your what? Margin of error. And there's the dictator. What's the dictator? 90%. Confidence what? So somebody look at 90% and give me the z-score so we can write it down before we even start.
1.645.
Okay, and in A, they give us p hat is equal to 0.10. Therefore, somebody tell me what q hat is. What's a dime away from a dollar?
90.
1.
90 cents. So I didn't do any math. I just wrote down what they gave me. And now I'd plug and chug into the formula. N is equal to PQ Z over E. Now you can't put 2 percentage points in as 2%. You have to change it to what? 0.02. So plug and chug. N is equal to 0.1 times 0.9 times 1.645 divided by 0.02 raised to the second power. Let me ask y'all a question. If you were an engineer and you were designing a building, would you design the building to hold up 200-pound people? Or would you design a building to hold up 300-pound people?
300 pound.
Why would you do that?
More can be in there.
Overestimation. Overestimation, I can't spell. overestimation, that don't look right, but overestimation, that's supposed to be an I don't know, is another word for cover your backside. Why would you want to overestimate to 300 pounds if you had your choice between 200 pounds and 300 pounds? Mr. Yates said, so more people could come in there. If you have everything based on 200 and you've got 300, then you won't have the building fall in. Okay? You're overestimating. And I would always say, always round up, because is there any such thing as 0.2 people or 0.8 people? No. So when you're talking about a body, you're talking about people, you're always going to round up, whether it's 182.2 or whether it's 182.5. You're going to round up. Now, for CYA, if you're doing a research grant or doing a research project and the end says do 190 people, are you going to do 190 people or are you going to do 200?
200.
200.
You're going to do 200. Remember the law of large numbers. The more you research, the better. So in that case, somebody tell me the decimal that you get. When you do this, somebody tell me what you get. Give me 2 decimal places.
608.86.
Okay, the book tells us to round up, so that would be 609 people. That's the answer. If that was 608.26, it would still be 609. Of course, if you were in the real world, you wouldn't do 609. You would do 610 or 625 or maybe even 650. So here you would do 610, 625, or maybe even 650. Real ambitious, 700. But that's the real world. Okay? 609 is the answer to this problem. But I would probably do at least 625 if I was sending out surveys, or 650. Okay? And that's the 2 type questions that you're going to get. Now, the B portion, look what B says. You're going to use the same material, the same numbers, except B says the economist does not use any prior statistics. So in other words, 0.1, there ain't no P. Okay, so P not given. That's the second type question. What do you do if P is not given? Well, I'm going to ask you one question. What's the probability of me flipping a coin and getting heads?
1/2.
Well, you got that, and it wasn't given. How did you get that?
X over N.
Well, you basically, yes, you knew that by putting X over N, but you knew it because how many sides of a coin is there?
There's 2.
Okay, so if you send out a survey, either they're going to say yes or no, or they're going to say, I do this or I don't. So we're going to say 0.5 is equal to P hat. Therefore, 0.5 is equal to what? Q hat. So if P is not given, you're going to treat the problem as a binary, meaning that there's only one of 2 what? Answers. Okay? Now, what is 0.5 times 0.5?
1.
0.25. No, it's 0.25. So if P is not given, your formula is going to look like this, and now you know why. It's going to be N is equal to 0.25 times Z over E raised to the second power. And that 0.25 comes from you saying either it's going to be a yes or a what? No. It's either going to be heads or it's going to be what? Tails. It's either going to be I do this or I don't do this. And that's going to give us 0.25 times, what was our Z, 1.645 over 0.02. Somebody crank this out, please. And give me 2 decimal places.
I got 1691.27.
So that would go up to 1692. 1692 is your answer. Of course, I would do 1700 at minimum. If I was in the real world, I would send out 1700 surveys, or 1725 or 1750, probably up to 18, but that's as far as I would go. Now, why did this go up? Because you are what? Assuming something. And we all know what happens when you assume something. Now, is that a good thing that this went up when you assume something, or a bad thing?
It's a good thing.
It's a good thing, because if you're going to assume something, you're not basing it on what? On mathematics. So naturally, the number of people you survey, if you're unsure, is it going to go up or is it going to go down? Large number rule. What do you want to do for accuracy? Have more what? Numbers. So if you're assuming something and you're not basing it on statistics. That was my mouse. It just fell on the floor and just went all to pieces. All the batteries going all over the place. It's one thing I hate about a hardwood floor. All right. So if you have statistics at P is equal to 0.10, what is that going to do to your N? Make it bigger or make it smaller? It's going to dial it in a little bit more. So if it dials it in a little bit more, it's more accurate. But if you assume something, what's that going to do to make it more accurate? It's going to make your N get bigger or smaller?
Bigger.
It's going to make it get bigger to cover for the assumption. Because you should never assume. Why? Because it makes an ass out of you and me. I guarantee you somebody in here has never heard that before. It's your parents' fault. People want to start a revolution, they can't even start a dadgum lawnmower. All right. Can't even make a sandwich. Make a complete sentence. All right. All right, let's go to the questions. That's 9.1. Now let's go to the, I can't go, let me just use the track mouse. All right, here is our first question.
Hubert, I have a question.
Yes.
If you're looking at a poll and it says the margin of error is plus or minus like a percentage, what does that mean?
That's the margin of error. That means that it's good within, if it says, hold on. Hold on, I'm trying to get my mouse back on the screen. Will you come here and give me my mouse and get that battery over there, please? Thank you.
Was it your goodness? Why don't you use goodness?
Because it doesn't work half the time.
Yes, it does.
Okay. All right, here we go. If you look at a poll and it says margin of error is equal to 3%, all right, that means that the accuracy is going to be, you know, within 3 percentage points. So if you've got John Smith at 47%, and you've got Jane Brown at 50%, then statistically they're what? They're tied. Because what is the difference between 50 and 47?
3%.
3. So that 3 percentage points covers the error in those 3% right here. Okay. Now, what if Smith was at 20% and Brown was at 70%? Would the margin of error play into this? No, because that's a landslide, which I'm praying for. Okay, that's a landslide. So, you know, if you have a close race and you've got a 7% margin of error, that's not worth anything. Okay. Usually, they also supposed to tell you what n is equal to on the bottom of a poll. If this, the lower this is, the what on n, the higher n is. A national poll that has, we have 350 million people. If you look down at the bottom and it says n is equal to 100 and the margin of error is equal to 6, this is what's called a subjective poll. It's called subjective. Does anybody know what a subjective poll is used for? A subjective poll is basically propaganda. A subjective poll is not accurate. A subjective poll is being used by somebody with if you get a national poll with 350 million people and you look down at the bottom and n is equal to 100 and the margin of error is equal to 6, this poll should not even be put in the magazine or on the air or in the book or anything. It should be lying in the bottom of a bird cage. So that's what margin of error tells you. If you had a national population of 350 million, you should at least have 3,000 to 30,000 on n, at least. Okay, now let's go to those questions. We put the batteries in backwards. I'm sorry, y'all. Just hold on. Some damn Russians. Miss Woodward, are you Russian?
No, I'm German.
Oh, she's German. Them Russians and Germans don't like each other too much. All right. Let's go down here, and I'm just going to pick, let's see, this is 15. There's about 3 or 4 of y'all sent this one. 15/4. Let's see if I pick the one that I've got right here. 70 and 32. Okay, this is a good test question. These are the type of test questions I ask. How many test questions you got right here? There's 3. So write down B, C, and D. Those are 3 good test questions. I wouldn't try to ask you this on a test I don't like giving full part. I don't like giving those. All right, so go ahead and write down the question. And I want you to draw a picture. Go ahead and draw a picture of it. Why did you ask that, Miss Billy? Have you seen a poll lately, or?
Yeah, saw some polls and it said margin of error, and then it had plus or minus, like for example, like 3%. And I was just wondering what that meant.
Yeah.
So it's within
3% below is good. Tolerable.
That's good to know.
Yeah.
Like with news, because you never know what's true and what's not.
That's true. I tell you, one of the biggest problems with our country right now is our media. And that's all I'm going to say. So I'm going to go ahead and draw a picture while y'all are drawing a picture. $70. And why can't they give you a 30 instead of a 32? I hate it when they do that. So that'd be 102 and 134 and 166 and 70 minus 32. I have no idea. 38. And 38 minus 32 is 6. And I'm some negative number. I don't care about that. They're not going to ask for a negative number, especially with people. Okay, so if we were in chapter 7, I would say, chapter 7, I would say one of two questions. I would say, what is the probability above 102? 102 above. Or I would say, what is the 30th percentile? That would be 0.3000, which is inverse norm. Inverse norm. And that would give you a z-score. Here, you would change 102 into a z-score, or use your calculator, minus 70 over 32, and then get an area. Y'all remember doing that in chapter 7? Okay?
Hubert, all I can see is the question.
Oh, I'm sorry. There we go. So this is chapter 7. Y'all remember doing that? Okay, so the first part of the question, nobody should have a problem with. Okay, now A, it says, choose the correct description of the shape of the standard distribution. It's approximately normal. And most of these and the ones I give you on the test are going to be normal. Okay, so most of them that I'm going to give you are going to be normal distribution. The mean usually is going to give you the mean of X bar. Okay, so in this case, the mean is going to stay 70 because it's a normal distribution. So it's going to stay the same. So the mean is the MX is equal to 70. Now I want to ask y'all a chapter 8 question. and I went over this, so you should be able to answer it. Is the standard deviation, which is mean up here, is 70, and the standard deviation is 32. Is the standard deviation going to change or stay the same?
Change.
Good job. It's going to change, and it's going to be called sigma x bar, because they give us n is equal to 64 in the question. Now, I want everybody to go to your question right here, and I want you to highlight where it says n is equal to 64. Where is it? Right there. I want you to highlight that. And the reason I want you to highlight it is because you need to write something beside it. You need to say Chapter 8, new standard deviation. That's the difference between Chapter 7 and Chapter 8. So now I've got to find a new sigma x bar. And that is the standard deviation over the square root of what? N. And I need you to highlight that in your notes because I gave it to you yesterday, which is Tuesday. I gave you that Tuesday. So what is our standard deviation? 32 divided by the square root of 64, which is 32 divided by 8, which is what? Now you will be tested on this, so you better write this down because this is a test question. So now our mean is 70 and our standard deviation is 4. And the question they're asking is, what is above 77? What is below 61.6? And what is between 64.8 and 80 or 79.6? So I'm going to draw a new picture. And this time, what is M? 7 or the mean is 70. And what is the standard deviation?
4.
4.
4. And this is based on those 64 people that was picked after the survey. Uh, 66, 62, 58. Y'all check my math. Now, what numbers are above, what does it say? 78. Well, 78 is somewhere up here, so I'm going to just put, no, did I say 78? 77.8. So I'm going to do 77.8 in blue. 77.8 be right in here. Minus 70 over, my new standard deviation is what? 4. So somebody crank that out for me and tell me, give me a z-score. So that's going to be That's going to be
1.95.
I'm sorry, what?
1.95.
1.95. So the z-score for, what was it? 77.8 is equal to 1.95. So they want to know above 77.8. Now I'm doing this for an old calculator. If you have a new calculator, do you have to calculate that z-score? Yes or no?
No.
What do you type in instead of the z-score? You type in 70
Upper.
and yeah, you mean and your what? Standard deviation, your new standard deviation. And then you type in 77.8. And what's this arrowhead called down here? Positive infinity, which is what? 9999. So somebody, either with a new calculator or an old calculator, if you have an old calculator, normal CDF, 1.95 to 9999. If you have a new calculator and type in 70 and 4, then it would be 77.8 to 9999. Both of you will get the same answer, and give me 4 digits, please.
0.0256.
Somebody confirm that, please. That's what I got.
Hubert,
So,
is
yes.
there any way you can do it in the new calculator real quick?
Yeah.
I'm not getting the same thing.
Okay, so take your handy dandy calculator. Second CDF or second VARS, turn it on first. Second VARS, normal CDF. Okay, if you do it new, 77.8 to 9999. Mu is 70 and 4. 0.0256.
Okay, thank you.
Mm-hmm. All right, now y'all do the second part. I'm going to do it in a different color. And the reason I want y'all to do it is because these are test questions. What is less than, what's the probability of those 64 people having a score or whatever this is? It doesn't say a score, it just says, I don't know what it is. We'll just say score, okay? What is the chance, what is the probability that out of those 64 people, what is the probability that they scored below 61.6? Draw it on your new curve, draw 61.6, and then what is less than, to the left or to the right? To the left. So I'm going to draw it on your picture for you. And we used blue, so I'm going to use something, let's use that nasty yellow that y'all can see better. Okay, what did it say, 60 what? 61.6. 61.6 would be right in there. And they want to know to the left what's less than 61.6. Now, if you've got a new calculator, you don't have to do anything but plug and chug. But if you have an old calculator, what are we going to have to change that 61.6 into? A z-score, Hubert. Thank you, class. Y'all suck.
The z-score is going to be negative 2.1.
Okay, hold on. Go ahead and do it. That milk was not wrong on the top shelf. The milk was not on the top shelf. Now, when I did that, I got 2.1. What did y'all get?
That's what I got.
Okay, so 61.6 minus 70 over 4. I got negative 2.1. And what's this arrowhead called down here? Negative what?
9999.
Yep, negative infinity, which is negative 9999. So if you've got an old calculator, you're going to go from negative 9999 to 2.1. If you've got a new calculator, you're going to put in 70 and 4, and you're going to type in negative 9999 to 61.6. And I got, y'all check me, 0.0179.
Yeah, that's what I got.
Yes.
All right, do the last one. The last one says between 64.8 and 79.6. I'm not going to help you on this one. Y'all got to do this one. If you can't do it, then that means you're a failure and probably should quit school. Get a job. Where do you work, Mr. Yates?
I did work at an insurance agency, but I left that not too long ago.
You got tired of it?
Yeah, insurance business is not for me.
I tell you what, it takes a special person. I know too. Excuse me, I got corona and dying. I got 2 or 3 friends. I got 2 or 3 at least in the world, and they're in the insurance business, and it takes a special person to do that. I couldn't do it.
Yeah, it does.
There is money to be made in the insurance business, but you have to hassle people all the time, and I'm not a people hassler. I'm a recluse. I want to get away from people. The only people I care about really is my students. That's about the only ones I care about. I mean, I care for my kids. I mean, I'm talking about just general population. I don't want you to think I hate my kids or anything.
Yeah, that's
All
a given.
right. Let's go with, haven't used Grenade Verde. I haven't used that yet. So let's use Verde. All right, 64.8. I'm going to just put it right about there. 64.8. Oops, I'm sorry. And 79.6. 79.6 is in here. So we're looking for this area right there. So if you have an old calculator, 64.8 minus 70 over 4, and I get 1.3. And then here, 79.6 minus 70 over 4, and I got 2.4. So somebody do a normal CDF. You don't have to do your 9 nines now because you got the z-score on the left and the z-score on the right. I come up with 0.8950.
That's what I got.
That's 3 good test questions right there for 8.1. So I would keep that in your, notebook because there's 3 good questions for your, and that's the type of questions I'm going to ask. I'm going to ask above, below, between. And I'm not going to ask you how many people attended Wimbledon and what were their addresses, like some of these questions do. All right, let's look at the next question. The first 2 questions that I looked at, because that covers all of these questions right here. The first 3, that covers Miss Woodward. Did that help you? And Miss Billy, did that help you?
Yes,
Yes.
that helped a lot.
Okay. Now this is number 19/5. And I like this one. I'll tell you why. I don't like it as a test question, but I like it as a homework question. In fact, this is a good question to show you for class. Why? Because it tells you to do chapter 7 and 8. So everybody can do this. Go ahead and write this one down. It says, suppose the length of the pregnancies of certain animals are approximately normal distributed. Draw a picture. That's what that means. 45, 145, and 15. And then it says, what is the probability that a randomly pregnancy lasts less than 139 days? That's chapter 7. So go ahead and do it. Everybody in here should be able to do this problem. I'm going to find it. I did it. Let's see. Oh, yeah, here it is. And this one has like 15 parts. So you probably got 3 or 4 test questions on this one. So I'm going to do this one in black because it's chapter 7. I'm just going to write the basics down. Let's see, 145 and 15 would be 160, 175, 190. 130, 115, 100. And they say a pregnancy lasts less than 139 days. 139 days, well, let's see, this is 15. Half of 15 is 7. So that would be 137, wouldn't it? So 139 would be right in here. And we want to know the area what? To the left, because left means less than. So somebody take your handy dandy calculator, whether it's a new one or an old one. If it's an old one, then 139 minus 145 over 15, which is equal to, what is that? 139, is that 6? Negative 6 over 15, which is equal to negative 2 over 5, which is equal to negative 0.4. I got negative 0.4. So I need somebody with an old calculator to give me negative 9999 to negative 0.4 and tell me what you get as far as an area. 4 digits, please. Or you could type in negative 9999 to 139 with a mean of 145 and a standard deviation of 15. It'll give you the same number. Give me 4 digits.
I got 0.3446.
Yep, you're right. 0.3446. And that is that area. Now you have just done a chapter 7 problem. There is nothing chapter 8 about this. This is 100% chapter 7. Now let's see what B says. Or whatever. I'm not going to. That means that if 100 people were surveyed, 34 of them would be below 139. 34. If 100 people were surveyed, 39 would be below, or 34 would be below 139. So that answers that next problem right here. Let's go ahead and show you what that says. Okay, 3.3446. Now, why do I not pick B?
Because it says exactly.
Exactly. That's another word like perfect. Okay? If you use the word exactly and perfect in real life, it's usually non-real. If you think about it. Like the perfect spouse or the perfect boyfriend or the perfect girlfriend. Doesn't exist. Okay? Exactly. I'm going to get it exactly on 4.8. No, that's not going to happen. Anytime you see the word exactly, perfect, impossible, any of those words that just don't feel right in a math class, it just don't. Those words don't feel right. So B is not it. So you can mark B out because it's got a perfect word in there. It's got one of those words that we don't like. We know it's not more than, so it's not A, so that means it's what? C. And we would expect, move the decimal place 2 places to the right for that 100, that would be 34. Okay, here's B. Suppose a random sample, ding! I'm going to take my handy-dandy black pen and throw it away because now I've got to use a green pen because I'm going to do chapter 8 now. B. And that doesn't look, that's green. I don't like this green. That green, does that green look like green or does it look black? Looks black. B, N is equal to 17. So that means I've got to get a new what?
Standard deviation.
I've got to get a new standard deviation, of course. And I got to draw a new bell curve. So that's going to be, oh, well, that's going to be, standard deviation is 15 divided by the square root of 17. Yeah. That was my calculus teacher. And he would go, yeah, and he would put those 3 dots. And that meant you should be able to do this on your own. So the standard deviation of the new mean is going to be equal to, let's see what I got. I got 3.64. Y'all check me.
That's what I got.
Okay. So I'm going to go over to my handy dandy next page. My mean is going to stay the same. Remember, we told you that was going to happen. So if y'all don't mind, I'm going to use 4 for standard deviation. You use 3.64, okay? So 145 is in the middle. And I'm going to use 4. So that's going to be 149, 153, and 157. Of course, y'all would have decimals. Please don't judge me. Okay? 141 is 4, yeah. 137 and 133. Okay, again, y'all will have decimals. Now let's go back to the question. The question says, suppose a simple random sample of pregnancies describe the sampling distribution, blah, blah, blah. The sampling of distribution X is normal with a mean of, they're asking you to, with a mean of 145. This is when I said the mean doesn't change. And the standard deviation is 3.64. They're asking you to confirm your calculations right there that we just did. Okay? Okay? Really? Okay, I rounded. I'm sorry. Sue me. Okay? What is the probability, blah, 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 has a mean gestation period of 139 or what? Less. So where is 139 on your new graph? Well, 139, well, there's 137. Right there, 139 is right here. So they want to know 139 minus 145 over 3.638. Was that what it was? Oh, excuse me. We got to hurry up. What time's class over?
235.
Okay. So that comes out to be negative 1.65. Y'all check me. And somebody go from negative 9999 to negative 1.65, please. What do you get? The 0.0495. Point 0495. 0.0495. Yep. So that means that 5 people, the days are less. So 5 people. All right, here's the last one, I hope. I don't know. What is the probability? 30 pregnancies. 30 pregnancies. I'll do that in pink. 30 pregnancies. N is equal to 30. Well, that's going to give us, yeah. So go ahead and give me that new standard deviation. So that's going to be square root of 30 over 15. Or no, yes, 15, the original was 15, yeah. All right, so what is 15 divided by the square root of 30? I get 2.74. Yes or no?
Yes.
Great, thank you. All right. Now I got to change 139, which is down here. Of course, I'm not going to draw another bell curve. Okay, so if you want to, you can. I'm going to draw a little one right here. 1, 2, 3, 4. 1, 2, 3. There you go. And 115 is in the middle. 145 is in the middle. And this is close to 3. So that's going to be 148. That's going to be 151, 154, 142, 139, 136. And they want to know what's below what? 139. 139 is going to be right here. So that number 139 is going to be 139 minus 145 divided by 2.74. Now I need somebody to give me 2 digits. Well, I did it. I got negative 2.19. And that's your z-score. And when you go from 9999 to negative 2.19, this area right here is going to come out to be 0.0143. And that is your answer to the last part. So there's 3 good test questions right there, and I'm going to have to stop right now. That's 3 good test questions. We'll continue with questions. I want to try to get, Tuesday will be our last day, and there'll be questions. I'll go over as many questions as I can. But I would ask you to try to work on the problems. I see a lot of questions coming in that I've already went over, but you know, try to do them. I want to try to cover as many as I can, but I don't know if I'll be able to because I only got 1 day left. So anyway, let me go ahead and finish that out. I'm going to go ahead and now that I've got my monitor, I can actually pull y'all up now and see who's here. And I can stop the recording and